Hey, this is Mr. Ng. I'm going to go over the Precalculus Chapter 2 test, taken November 4th, 2019. This is version W. Multiple choice, circle the best answer. Multiple choice, write the equation of the parabola given the vertex 0, 3 and the point negative 1, 5. So I see the word vertex, and automatically I'm going to write vertex form for quadratics. And this is my h, and this is my k value, and this is my x, and this is my y. So essentially what you're going to do first is you're going to solve for a. Solve for a. So my y coordinate is 5. A is what we're trying to solve for. My x coordinate is negative 1. And my h value is 0. And k value is 3. Negative 1 minus 0 is negative 1, and negative 1 squared is just 1. So really it's 1 times a, or you don't need that 1, right? The coefficient is always 1 there, so I'm going to subtract 3, and then a is equal to 2. So then now I'm going to make my equation by just substituting back into the vertex form, which I wrote here. And what you're going to use is just the vertex and the a value. The reason why you don't write anything for the x and y, because that's any point on the graph which is a solution. So y equals 2 times x minus 0 squared plus 3. Or y equals, this just becomes x, so that's 2x squared plus 3. And then this would be choice D. Question number 2. Shouldn't have 52 there. List all the potential rational zeros of the polynomial. Do not find the zeros. So you're going to take your last over your first. Last, which is P over your first. Q. And then you're going to have the factors of 6 over the factors of, now, take 4. Not just negative 4. I know it says negative 4 there, but and we're going to list out all of our factors. So the factors are 1 times 6 and then 2 times 3. And the factors of 4 are 1, 2, and 4. Then from here, then we talked about dividing through. So you're going to have 1, 2 over 1, 3 over 1, 6 over 1. So that's just going to be 1, 2, 3, and 6. And then you have the 2's, so you have 1/2. 2 over 2, which is 1. And then 3 over 2. And 6 over 2, which is 3. And then I didn't mean to have a fraction line there. I'm just writing all the numbers. And then 1 over 4, 2 over 4, which is 1/2, 3 over 4, and 6 over 4, which is 3/2. And then you can just cross off all the duplicates. So I see 1. When I say cross off the duplicates, what I meant by that is you're not going to test the same number twice. So 3 halves, 1, 2, 3, 6, 1/2, and 1/2 there. So let's go ahead and look for the ones I have. I have 1, 2, 3, 6 here. I see 1, 2, 3, 6. I see 1, 2, 3, 6. This one has a 4, so not this one, and not that one. Okay. Then my fractions are, I have 4 fractions. 1, 2, 3, 4. And this one has 5 fractions. This one has an extra 2/3 there. So D would be my answer. Just double check. 1/4, 1/2, 3/4, and 3/2. So D would be the correct answer. Question number 3, make sure to show all your work and box your answers. I did tell you guys to factor completely and graph and to label your intercepts. Okay, so how do I factor this completely? I have 4 terms, and I'm going to take a chance at factoring by grouping. So I'm going to put this into the box. 5x to the third, 25x squared, x, and positive 5. Greatest common factor in this direction, let's use a different color. I have 5x squared, this direction is x, 5, and this would be a 1. Okay, so let's write that out. I have 5x squared plus 1 and x plus 5. And what we have here is my factored form. And you'll recognize that if I try to factor that one again, this is my a, this is my c. So a times c is 5, b value is 0. There are two numbers that will multiply to be 5 and then add to be 0. Remember, adding to be 0, these two numbers have to be the same, but one positive and one negative. So we factor this completely, and now we need to find their intercepts. Well, to find a y-intercept, you make x equals 0. And if I do that, I'm going to get 5 times 0 to the third power times 25, 0 squared plus 0 plus 5. And essentially what you have is just 5. 0, 5. So I know my graph's going to go through 5 over here. X-intercepts is what we have here. So you can put 5x squared plus 1 equals 0, and x plus 5 equals 0. So here, x-intercepts. Subtract 1, 5x squared equals negative 1. Divided by 5, x squared equals negative 1/5. And then if I take the square root, you're going to get a x equals a plus or minus the square root of negative 1 times 1/5. The square root of negative 1 is I. So I have x equals I, and then radical 1/5. This is going to become radical 1 over radical 5, which is 1 over radical 5. And then you would rationalize the denominator, so radical 5 over radical 5. And so your answer would be radical 5 over 5. So you'll notice that the I, we're going to put that right here. So I radical 5 over 5, and that's plus or minus. So this one here represents two solutions. So we have two imaginary solutions. And over here, subtract 5, x equals negative 5. So there's my real. So one real plus two imaginaries, 1 plus 2 gives us a third degree polynomial. Last thing I'm going to check is probably the leading coefficient. The leading coefficient here is a positive. What does that tell us? Well, this is an odd degree, so 3 is odd. The easiest odd I know is a first power. And so that tells me starts down, ends up. And because this is positive, it's going to stay the same. So let's go ahead and do that. So my leading coefficient starts down, ends up. I know that there is a x-intercept at negative 5. This is multiplicity to the first power. How do I know that? This is to the first power, so it's going to be a shoot through. And somewhere there's going to be a bounce at an imaginary. So my graph could look something like, let's see. It's a guess, so let's just double check. 5x to the third plus 25x squared plus x plus 5. Zoom 6. Means I'm going to have to go a lot higher on the y values. So y, do like -1, and maybe this is 100, and then count by tens graph. Okay, so now we got something a little more accurate, but at least by hand we kind of had a good idea what the graph looked like. It's going to go through -5. It kind of went way up there. Eventually came down to the 5 and then did their bounce right there. So something like that. And then really what I'm looking for is I'm supposed to go through this -5, right? And there's your sketch. And what's the question? You will have, what kind of weekend? What are you doing this weekend? Whatever you're doing, it better be fun, safe, and legal. I'll probably give 1 point for all of those, and then 0.5 for at least one. All for one. So front side, 2 points, 4, 6, and that one's 10. So that one's at 2 points. Alright, question number 5 on the back side. Make sure to show your work in box of answers. Write a polynomial function of minimum degree in standard form with real coefficients using zeros R. 1 with a multiplicity of 2. What does that mean? You're just basically having the same number twice. You have positive 3i, and then you should have, remember, complex numbers come in conjugates, so that would be negative 3i. So you're going to have a 4th degree polynomial. Let's go ahead and put that in. And then I'm just going to put in all of these numbers right here. Let's see if we can zoom in more. So I'm going to put in there 1, 3i, and negative 3i. So we get x minus 1 times x minus 1, and then x minus 3i times x plus 3i. And then what I'm going to do is I'm going to go ahead and use the box. Now, you can multiply these in any order, but I would multiply the imaginaries together and then the reals together. So I'm going to multiply this one way at the bottom so I have plenty of space. So now I have x minus 1, x minus 1. I'm going to multiply first, so we're always going to do this first. Multiply, then we're going to add. So x times x gives me x squared, negative 1x, negative 1x, positive 1. And if I combine like terms, I get x squared minus 2x. These are like terms right there, and then plus 1. And you can go ahead and put check marks to make sure you've touched every single one of those boxes. And that is my answer for the yellow right here. Okay, now I'm going to multiply the greens, and we're going to get an answer, and we're going to put it right there. So now we have x minus 3i and x plus 3i. We're going to do the same thing. We're going to multiply, then add. X squared, 3ix, negative 3ix, put in the same order, and then this is a negative 9i times I is I squared. So you have x squared by itself. These are exactly opposites, right? Positive negative 3 and a positive 3. So these will equal 0. Remember, I squared is equal to negative 1, so negative 9 times negative 1 gives me a positive 9. So essentially I have x squared plus 9. X squared plus 9. And what I'm going to do is now I'm going to multiply the yellow times the green, and we will call that our answer for the orange. So let's go ahead and put a box there. And if you want to know how big my box is, I have two terms here, 1, 2, and this is 3, 1, 2, 3. So a trinomial times a binomial gives us a box of 6. So let's go ahead and draw out that box of 6. And up here I'm going to put in x squared minus 2x plus 1 and x squared plus 9. X times x is x to the 4th. That becomes negative 2x to the 3rd. X squared. 9x squared. Negative 18x and 9. And then there I'm just going to combine like terms. The only thing I noticed that are like terms here is a 1x and a 9x. So that gives me 10x squared. So let me go ahead and just write that really far up there. Let it focus. And then now I have x to the 4th minus 2x to the 3rd. We're writing this in descending order. My degrees are going down. 10x squared minus 18x plus 9. And that would be our answer right there. Alright, question number 6. Write the cubic function. So I know my answer is going to be cubic for the graph shown. Okay. So let's see what we got here. It says I have a x-intercept at negative 3. So x equals negative 3. I have another one at x equals negative 1. And I have another one at x equals 2. And then I have this random order pair up here, negative 2, 4. So I have x and I have y. So here you have, we can just put this into something like factor form or intercept form. Y equals a times x minus p, q, and r. And then those are just my values that I'm putting in here. And don't forget that minus sign, so be careful. See, I try not to highlight it this time. That's better. That's my r value. And then essentially we're going to do the same thing we did on the first question above there. We just need to find the a value. So my y value is going to be 4, and every x value is going to be negative 2. So let's put that in. So y value is 4. My a value we're going to solve for. X is negative 2 minus your p value, which is negative 3, so be careful there. X is negative 2. Your q value is negative 1. X value negative 2, and r value is 2, not 20. Let's go ahead and just simplify and solve for a, and then plug it back in. 4 equals negative 2. The opposite of negative is positive 3, so that becomes 1, and so I'll just put 1 in there. That becomes a positive 1. Negative 2 plus 1 is negative 1. And negative 2 minus 2 is negative 4. And then you multiply all of those, you get a positive 4. A is equal to 1. Okay, with an a value of equal to 1, I'm basically going to put in the yellow, orange, pink, but not the purple. And the reason why I'm not going to put the purple into my final cubic function is because this represents just one solution, and then my equation should represent how I find all the solutions. So I'm just going to basically use that formula again. Y equals 1 for my a value, x minus 3 became plus 3, and then that becomes opposite of negative 1, so plus 1. and then x value, and then my r value is 2. So this is a cubic function. Not so easily seen, so let's just, I didn't state if I should have it in standard form or kind of like factor and intercept form, so I'm just going to multiply those out. So x plus 3 and x plus 1. Let's multiply these first two, that's my answer, into this green one here. X squared, x, 3x, 3, and so that becomes x squared plus 4x plus 3, and then we're going to multiply that by x minus 2. Still got blue. X minus 2, x squared plus 4x plus 3. X cubed, 4x squared, 3x, negative 2x squared, negative 8x, and minus 6. Double check that. Okay, and I get x cubed, these are like terms, so 2x squared, negative 5x, and negative 6. So I didn't tell you guys specifically which one, so if you have either of those answers, will be acceptable. Question number 7, thanks to Shyla, 5th period, thanks for catching that. So we have to change that one to a positive, and then we have 4 terms, so we can gamble by trying to factor by grouping. So if you put that as a plus, so I got 4x to the third, that's supposed to go inside, 4x to the third minus 3x squared, 24x, and negative 18. And then my greatest common factor here is x squared. This one's going to be a 4x. And then here going to be a negative 3. And this one's going to be a 6. X squared times 4x gives me 4x cubed. X squared times negative 3 is negative 3x squared. And then 4x times 6 is 24x. And 6 times negative 3 is negative 18. So this will factor to be 4x minus 3 and x squared plus 6. Okay, from there I'm just going to set that both equal to 0. 4x minus 3 equals 0. And x squared plus 6 equals 0. And so I'm just going to solve here, so I'm going to add 3. You get 4x equals 3, and divide by 4. X is equal to 3/4. And over here you have, we need to subtract 6. X squared equals negative 6. Then I'm going to take the square root. When you take the square root, you have both positive and negative. You have the square root of negative 1 times 6. This becomes I. The I goes to the left of the plus or minus. Alright, left of the radical. And so you have one positive, one real, one complex of positive I rad 6 and negative I rad 6. So that means you have 3 zeros, 1 real, 2 imaginary, so that gives me the degree of the polynomial. And then I'm just going to plug that into my graphing calculator just to double check. So 4x cubed minus 3x squared plus 24x minus 18. Let's see what it looks like. And really, this is all you really need to know, is that it's going to just crossing at 3/4. Let's change the window. When x min -1, x max maybe. I didn't see a graph come back down, so let's say 50. Count by tens. Y minimum, sure, -10, and let's go to 100 and count by tens. Kind of want to know what the squiggly looks up there. Let's go to y max of 1,000. Let's try 100 here. Let's double check. 4x to the third minus 3x squared plus 24x minus 18. Okay, let's try. Let's try this one at 25. Count by 5s. Y minimum. Let's go to 10,000. And let's go to 1,000. Okay, so all you really need to know is on that fresh graph that's crossing at 3/4, and it's not coming back down because there's an imaginary, which means it only crosses the x-axis at one place there. So 4, 8, 12 points on that side. So 22. Hope that was helpful for you. Good luck.